Good afternoon, ladies and gentlemen. My name is Matt Boyashin, Senior Solutions Architect, and today we're here to talk about architecting the VDI profile, or the role of user profile and user-installed applications within next-generation VDI with Profile Unity. So first, let's talk about a brief agenda. We're going to talk about understanding desktop transformation, the desktop transformation phases, persistent and non-persistent VDI and why that matters, segmentation of the user profile, including user registry settings, user intellectual property, provisioning tasks, which involves the depth of scripting. It's a very big thing we're going to talk about a little bit later. Non-persistent VDI application delivery, including image integrated applications, virtualized and streamed applications, and user-installed applications. And finally, the future state of operating system migration. Now, first, before we talk about anything else, we really need to understand what is involved with desktop transformation. So, a couple quick things. First, just designing a VDI environment isn't enough anymore. And this is because business units are demanding more functionality and flexibility. IT is trying to deploy this new technology at a lower cost. Hardware refresh rates are stagnant. Our software upgrade rates are increasing. Our operating system upgrade rates are also increases. And our device and operating system agnostic solutions are the key to deploying next generation VDI. And we're going to talk a bit about each one of these in the presentation itself. So first, let's talk about some other desktop transformation phases. And these might be some of the questions that you're asking on the proverbial crossroads of VDI adoption, such as how do we manage physical and virtual together? Is there an easier way to go about doing that? How do we create the best user experience for all of our workers? And we're not going to talk about all of the Liquidware Labs products here, but some of these questions are going to be dedicated towards Stratosphere UX, which stands for User Experience, and Stratosphere Fit, which allows you to assign specific users and understand what kind of virtual hardware they need when you transition them from A to B. Now, creating the best user experience for all of our workers entails Stratosphere UX. What happens when I need to migrate to Windows 7 is a question that we get asked quite a bit by Liquidware Labs clients. And the thing to remember is it doesn't matter whether we're talking about physical or virtual. Profile Unity is going to allow you to seamlessly migrate between Windows 2000 or XP or Vista seamlessly into Windows 7. So let's go to the right-hand side, and we need to ask, do I need VDI? And if so, where do I start? That's going to be relegated towards Stratosphere Fit, our assessment tool. How do I plan out a virtual desktop project? Again, relegated towards Stratosphere Fit. And finally, how do I manage costs and make sure I get my money's worth? Well, the big answer to that question is know before you buy, or plan before you buy, and that's exactly what Stratosphere Fit helps you with. And then finally, what happens if I get it wrong? That really uncomfortable conversation with the CIO that no one really wants to have. So our products are designed to answer all of these questions and prevent you from having to worry about getting it wrong, because you'll know exactly what you need before you go about building it. So in doing so, we have four major transformation phases that encompass the Liquidware Labs set of products. The first, in the top left-hand corner, is going to be assessment. Assessment allows you to categorize your users and your applications, identify good, fair, and poor virtual desktop candidates, spot your usage patterns and workloads, and baseline the user experience. Then we're going to move over to the design phase, which encapsulates identifying pilot and user workgroups, identify and create image, host, and storage design, developing a POC, or proof of concept environment, and then finally right-size the resources, performance, and total cost of ownership. Now, assessment and design are going to be basically positioned towards Stratosphere Fit, as well as Stratosphere Designer. Migration is really what we're here to talk about today, which is the VDI 2.0 architecturing profiles. It allows you to decouple the profile from the operating system, background migrate the user settings and data to the network, anytime migration to a platform, and leverage FinApp and user-installed applications. But it's not just FinApp we're talking about here. This can be AppV, SVS, or any other virtualization and abstraction tool in the marketplace today. And finally, the last piece of these is going to be the validation piece, which is going to allow you to validate the user's experience, tweak, tune, and scale, monitor the endpoints, hosts, servers, storage, domain controllers, and network, and finally give you predictive analytics as well as proactive diagnostics. Now, this entire big box is relegated to Stratosphere UX, which is our user experience monitoring and predictive analytics tool. Today, we're going to be talking about everything in the bottom right-hand corner in regards to migration to VDI and how to better manage that entire environment. So first, before we talk about the next generation VDI profile, let's talk about the existing form of VDI, which most companies are running today, which is persistent VDI. And we're going to compare that against non-persistent VDI and discuss why it matters. Now, first, persistent VDI, which is what most people have today, represents a one-to-one operating system to user ratio. For every one user, you have one live virtualized operating system. And that's very similar to current desktop deployment. Our images are stored in large flat files. Our applications can be either streamed or installed locally. But normally we found them installed locally because a lot of companies haven't adopted streaming very well just yet. The profile is usually installed locally as a result. OS upgrades are a painful process. Backups and restores are time-consuming. Corrupt images mean a large amount of user downtime. OS updates are heavy and slow. Expensive licensing, expensive storage, and expensive servers due to the machines being on all the time. Now, just a couple of things we're going to pick out and talk about as to why they are in such a current state of disrepair. So, when I have a persistent VDI session, that's just the exact same methodology as having your current physical desktop, but it's just installed in a virtualized server environment. So your application updates are usually going to be performed by some kind of a methodology tool like SMS or SCCM or Alteris. Now the problem is every time you update that application, the machine has to run it. And those resources required to installing an application are actually quite high. So understanding what kind of resources we can eliminate from this process is paramount towards increasing efficiency. And the same thing can be said for the operating system. If I'm actually pushing a Microsoft update to a system, those things are very big and they're very heavy. And if you'd like a little bit of proof as to that, go and open up a Windows Task Manager session while you're installing an update and take a look at some of the resources that are being consumed while you install an application or install an update or do anything like that. You'll find that you're using a lot of CPU, a lot of memory, and most importantly, a lot of IOPS, which are the second most expensive component of all of VDI. Licensing is going to be expensive because we're basically making all of those applications available on all the systems at once as opposed to worrying about concurrency. And storage, we're doing the same thing. We're having every single one of our machines live and on all the time just in case there's an update that they need to get. And as a result, our servers, because they have to house all this information, are going to be expensive as well. We want to try to eliminate that if possible. And now we get to talk about non-persistent VDI, which is also known as the holy grail of VDI. Now, non-persistent VDI is a relatively new technology. It's represented by a lot of different companies and hypervisors, and they call it something different. Microsoft and Citrix refer to it as streaming, as does Red Hat. VMware refers to it as linked clones. But in the end, the process is the same, which was what we're getting out of this is a concurrent operating system to user ratio. So if you have 1,000 people in your environment, but only 500 of those are online at any one time, that's how many machines that you have being allocated by the servers. Now, if we only have half the machines that we had to support before live inside of memory, then that means that the servers are going to be twice as agile, twice as fast, have twice the load on them. And as a result, the environment is much, much faster. So that gives us to a much faster than current desktop deployment because it means deploying new images is simply as fast as logging off and logging into that new image. It should really be that quick and that simple. Images are generally stored as clones with user data as deltas, and this is the case for any of the hypervisor. This is what we're talking about. Every single one of the operating systems is a fresh, brand new operating system install. Applications can either be image integrated, streamed, aka virtualized, or installed as user-installed applications. We're going to talk about all three of those different scenarios in a little while. Profile is usually installed remotely, which is going to have to be if we have a destructive desktop, because otherwise every single time I create a document or I install an application, if I log off, it's all destroyed. So we need to make sure that that user intellectual property is accounted for. OS upgrades are a pain-free process. We also have the ability for where corrupt images just mean a reboot. If we reboot, we get a new image. Image updates are much, much simpler because we simply update the master image and reboot all the virtual machines or recompose all those virtual machines. We have cheaper licensing, with the exception of the operating system itself because Microsoft has made VECD pretty much a one-to-one user to operating system license process. We have cheaper storage because all those idle machines are not constantly processing IOP requests, and cheaper servers due to only the concurrent machines being active at any one time. Now, this sounds great. What's the catch? Well, first off, as we discussed before, at log off, the machine gets destroyed, and as a result, the user data is immediately destroyed. And any application that's installed is also immediately destroyed. And according to the graphic in the bottom left-hand corner, that's a bad sign. So realistically, we need a way of decoupling the user profile and the applications in order for this to work. And that's where Profile Unity comes in. So Profile Unity allows for the segmentation of different sections of the user profile. Now, registry data is a large part of what makes your machine look and feel the way it does. And 80% of the user persona is carried over from the default user profile. So what Profile Unity functions on is that percentage that doesn't change, that stuff that actually is your user space, the stuff inside of the registry that you have made different since the importation of the default user profile. Now, these parts of the registry we care about can be broken down into two key parts. The user persona portion, which generally is stored as HKeyCurrentUser, aka ntuser.dat, and the machine portion, which is generally stored as HKeyLocalMachine. Now, native registry data ensures that programs will run as they should. If we have a non-native solution, so if we decide to encapsulate or virtualize or layer that registry, then that's bad because that's not native. And this is actually going to be doubly so for layering because layering is also not native. And this means that any application that is not compatible with this method is going to break. So by keeping things native, we're ensuring that the most amount of applications are going to be compatible with this method. So the idea to remember is look for tools that will natively allow for registry portability. And as it happens, Profile Unity is a native tool that performs these tasks. The next piece of the user profile we want to talk about is the user intellectual property. Now, the user intellectual property is the lifeblood of your organization. IP is reigning king as to what constitutes the majority of your dollars or your worth or your actual company, what it actually is made up of. It's made up of data. And the majority of that data is user-created or user-managed intellectual property. So as a result, you can never place too high a value on user intellectual property. And the funny thing to know about this is that in regards to our servers, our enterprise class servers, we spend billions of dollars each year just making sure that those are backed up and stored in a proper place and everything's being managed properly. But if you think about all the user intellectual property we have present on the thousands and thousands of desktops that may be present in your organization, a lot of that data is not being taken care of today. And that's a big problem because that means you're only one hard drive failure away from losing a tremendous amount of user intellectual property. The other thing to remember is that users can and will store data in places that they shouldn't. I've had some folks who store things exclusively in my videos and my music. Why? Well, that's just how they do things at home. So we need to support that kind of methodology of harvesting that data regardless. And users are also going to be slow or against adopting a solution that requires them to start over with the desktop environment. So if you're looking at VDI and you're looking at giving your using a blank slate every time that they get a new machine or a new operating system in VDI, they're going to be against that. You're going to have a very slow adoption rate. We want something that's going to integrate natively without layering. And we want to really allocate for tools that are going to harvest the data for you, making the transition to VDI and non-persistent VDI even easier. And that's exactly what Profile Unity does. It performs all these tasks and more. So harvesting all those different user shell folders that are present inside the center of the screen is what Profile Unity does. Making those things seamlessly available inside of a network resource that's properly backed up ensures that your user's intellectual property is being treated as it should. The next piece we want to talk about is provisioning tasks as well as the death of scripting. Now, a lot of organizations that we speak to are using scripting for logon scripts or processing tasks or doing a lot of things. And the thing to remember about scripting is it doesn't matter whether we're talking about DOS or VBS or PowerShell. All these things have the same thing in common. So first off, if we're looking for a product to help us decouple the user's profile from the operating system, why can't we expect more from it? So we already established that scripting is slow. And scripting is slow for the following reasons. First, it's emulated in DOS. There really is no more DOS inside of Windows. It's not like the 9X days. Ever since Windows 2000, DOS has been emulated, which means it's not native. As a result, each line is executed as a separate instance. It's not compiled code. It's code that's being compiled on the fly. And each passes are giving back to the native operating system. So each line that's executed then goes back to Windows and says, hey, I need a native way of being able to do this. Now, if you have antivirus added to the mix, which most organizations do, antivirus is going to scan each line of code before execution. Dependencies may limit the ability for you to execute scripts as parallel tasks. So as a result, this is kind of a double whammy. What antivirus is going to do is take a look at each line of the script and make sure that it's not a virus, and then put it into a repository and make sure that that portion of the code is not a virus. And then finally take a look at the whole thing and make sure the whole thing is not a virus. That's a lot of work. As a result, it's very, very slow. Now, on the human aspect of this, scripting is time-consuming for a lot of other reasons. We have a lot of hours spent creating scripts and troubleshooting scripts, and scripts run during login increase user frustration. Now, to give you a real good example of how we can eliminate most of this time that's wasted, well, let's talk about drive mappings, because that's what a lot of people use scripting for. So let's say I have 5 drive maps that are being executed via a batch script. Now, a net use command is going to take about 1.5 to 2.5 seconds to execute, so we'll call it even 2 seconds. And if you have 5 drive maps to execute inside of the script, that's going to add 10 seconds to the user execution of a script, or the login portion of the user operating system. You've just added 10 seconds to it. And users aren't generally happy about waiting for logins to occur. So if we do the exact same thing in Profile Unity, that's going to take about 20 milliseconds. So you've given the user 9.98 seconds of their life back every time they log into that system, thus making them that much more productive. So the tool that's going to pass the operating system kernel with a script will without the need to code is really what we need, and that's what Profile Unity does. Finally, we get to talk about non-persistent VDI application and delivery. Now, we're going to break this up into 3 different sections: image integrated applications, streamed applications, and user-installed applications. So a question we get asked a lot is, when should we put an application into the base image when designing for a non-persistent VDI environment? And the answer is, whenever an application is used by 80% or more of your user base, and your licensing allows it, then the application should go into the base image. And there's a lot of really nice benefits to this, such as we can get faster application updates but only need to recompose the function. So anytime we update the master image, we recompose, all the users get it, and we've just updated possibly thousands of machines with as little as a reboot. So all those resources that used to go towards updating an application inside of the live persistent VDI is now gone. As a result, we have better application version control. We can remediate bug fixes faster, and we can seamlessly upgrade to major new versions without having to worry about an update crash or being held responsible for an update storm or seeing your machines offline for a large period of time while we're updating these applications. The second big piece of this is going to be image virtualized and streamed applications. So the question we get asked again a lot, just like before, is when should we put a virtualized or streamed application out there for our users to use? And the answer is very simple. Whenever an application is used by more than 40% of your user base, and the application works with your streaming tools, you should stream the application. And there's lots of nice benefits to this, including the ability to have an application function where it was never meant to, such as IE6 inside of Windows 7. Lots of the companies that make these tools can make that kind of thing happen. Better application version control, faster remediation of bug fixes, and seamless upgrades to major new versions. Now, where Profile Unity fits in with this is that Profile Unity, especially when combined with a ThinApp environment, has the ability to control all of these packages for you. So you're no longer limited towards using a very messy, sloppy GPO function to control them, or using VMware View, which is kind of a little bit confined in the way that it does things. Instead, we can create filters for our user base and use those filters to control what applications go where. If a user needs an application, we simply add them to that filter, and we can automatically propagate the application to them very simply, very quickly, and very efficiently. Now, the only problem with this is that it's going to take time for your engineers to go and compile all these virtualized or streamed applications. This takes a lot of time. And ideally, you want to be able to deploy non-persistent VDI now. So how do we go about doing that in the seamless, easiest, fastest way possible? Well, the way we go about doing that is through something called user-installed applications. Now, within Profile Unity, there's a module called FlexApp that makes this method of user-installed applications a complete reality today. So we can actually purchase and turn on FlexApp and get all these intrinsic benefits that we're talking to today without waiting for it. So first off, what is a user-installed application and why does it matter? So user-installed applications, or UIA, is a new method of thinking about VDI and non-persistence. It allows us to install any application or package. In most cases, this involves the user interacting with an application installation as they normally would. Now, when the user logs off, the image that the user was using is now destroyed. The next time they log on to a non-persistent desktop, the application follows the user to that new machine. This allows the user to treat the non-persistent desktop just like their old physical desktop. Now, for all intents and purposes, the user no longer needs to know how to treat a non-persistent or persistent desktop any differently. Now, this is really a highlight technology that we've been waiting a long time for, because it's going to allow you to get all the nice benefits of non-persistent VDI, but without any of the headaches of it, and we get to treat it just like persistent VDI. So the other questions we get asked are, what should we look for in a UIA tool? Now, there's only a handful of tools out there right now that actually provide this functionality, and it's important to remember that Profile Unity is a native tool. So Profile Unity and FlexApp handle the UIA in a native function. So, number one, native is always better. 2, streaming and virtualization tools currently have a 65% compatibility rate. New native tools are exceeding this number by a large margin. In fact, when we're talking about FlexApp, FlexApp has a 99+% compatibility rating. So you can immediately see that there's no work involved in terms of making these apps available to your users, and you don't have to re-architect the wheel in order to make non-persistent VDI easy and seamless for your users. Your users don't have to learn anything new, and that's a huge stumbling block for VDI. You can also look for a tool that's going to help you manage your drivers, your services, your COM or DCOMs plus services, as well as side-by-side DLL management, and FlexApp does all these things. Now, these are areas that streaming struggles with. You want a tool that will complement your existing application sets and not detract from them. FlexApp is available as a part of Profile Unity and performs every single task that we just mentioned. Now we get to talk a little bit about future state. So when looking at the larger picture of profile management, the end result of this is kind of thinking is an ubiquitous way of dealing with user data. We're making things migrate between operating systems whenever we want. So just by having the user log in, they get their data. Then we're essentially allowing the users to do whatever they want as a result. And this has far-reaching implications into the realm of operating system migration and future state devices. So if we're talking about Windows 8, Windows 9, Windows X, getting to these new OSs has always been a very large headache for companies because they have to use migration tools, or it takes years and years to migrate to them. What if that weren't the case? What if we could use tools like Profile Unity and FlexApp to make those kinds of things happen in a matter of logging out and logging back into your new operating system? Well, that's going to change the way people work, and that's going to change the way we think about operating system migrations as well. So when your data and your applications are no longer bound by the physical PC or persistent VDI system that you use on a daily basis, you're free to move towards newer technologies without being encumbered. And this is ultimately the future of computing, to have the ability to have our data when and where we want it without worry or concern as to how our device can run it. This has a side effect of reduced costs, but the question is not why, but when. And with Profile Unity and FlexApp, when is now. How is with Profile Unity and FlexApp, and why is more like why not. So I wanted to thank you very much for your time, ladies and gentlemen. Thank you for viewing this video. If you have any questions that can be addressed directly to me, you can reach me at matt.boyajian@liquidwarelabs.com. If you have any sales-related questions, you can contact the sales department at sales@liquidwarelabs.com. And also, please feel free to reach out to our website where you can download trial editions of our products, see more videos like these, and get answers to any questions or documentation needs you may have. Thank you very much for your time, and have a great day.